Hi everyone, I am M.Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Engineering. Today we are going to see the topic of fundamentals of algorithmic problem solving in design and analysis of algorithms. This is the diagram of algorithm design and analysis process. This is the fundamental of algorithm problemic solving, breaking down each of the key concepts and techniques in detail in this video. And the first step is understanding the problem, then choosing the right approach, then design an algorithm, prove correctness, analyze the algorithm, code the algorithm. The first step is understand the problem. Before jumping to design an algorithm, we need to understand the problem clearly, and here is how we can break down the process. And steps to understand the problems are: read the problem statement carefully, pay attention to the input, output, and the relation between them, then identify constraints, that is, constraints or conditions or limitations on the problem, such as input size limits, time limits, or memory limits. Knowing these helps you design more efficient algorithms. Break the problem into subproblems. It means large problems are often made of smaller subproblems. Breaking the problem into parts allow you to address one issue at a time. Then choosing the right approach. Example, brute force. Once we understand the problem, we need to choose an approach to solve it. There are several techniques available, and the first one is brute force. What is it? Brute force involves checking every possible solution to find the correct one. It's the simplest approach, but it's often inefficient for larger data set. And when to use it? Brute force works well for a smaller data set or when the problem is simple and can be solved with direct enumerations. Example, checking if a number is a prime by test all numbers from 2 to the square root of the number. And then second approach is a greedy algorithm. Greedy algorithm makes the locally optimal choice at each step, hoping it leads to a global optimum. The idea is to build up a solution piece by piece, choosing the best option at each step. And when to use greedy algorithms, when we can make decisions that appear optimal locally and are likely to lead to an optimal global solution. Example, coin change problem, choosing the largest coin demonstration at each step. And the next technique is divide and conquer. Divide and conquer breaks a problem into smaller subproblems, solve each subproblem recursively, and then combines the result. This idea is to simplify the problem into smaller, more manageable parts. And when to use these techniques is when the problem can be broken into smaller, similar problems such as sorting or sorting. Example, merge sort. And the next technique is a dynamic problem. Dynamic problem is a technique used to solve a problem that have overlapping subproblems. Instead of solving the same subproblem multiple times, dynamic problem stores the result of subproblems and reuses them. This avoids redundant calculations. And when to use this dynamic problem is when the problem can be broken down into overlapping subproblems and optimal substructure. And then algorithm design techniques, or that is also known as algorithm specifications. It is in three types, that is step-by-step decomposition, pseudocode, test small cases, and then time and space complexity. Here time and space complexity. Big O notation is a way to describe the efficiency of an algorithm in terms of time complexity and space complexity. And 0 of 1, big O of 1, big O of n, big O of n square, these are the time complexity. And space complexity such as big O of n, constraint space, and O of n is a linear space. Then edge cases and testings, like what is it and when to test the algorithm, and then it is a iterate and a refine one. It must be short, start simple, begin with a simple approach that works even it is not optimal, refine it later. It often easier to improve a working solution than to start for a scratch. Then practice, 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 which is solving problems constantly, solve problem on platform like Lead Code, Hacker Rank, Code Force, develop our problem solving skills. Thank you.